Now we are going to continue lecture 3 through the part 3 about the Artificial Intelligence and Big Data course. Lecture 3, we try to talk about, two sections of 3 important sections. At the part 1, I explained that section 1 is foundation of data and knowledge. We are at the end of this stage, this section. And after finishing this section, we will touch to section 2, which is evolution of data handling practice. So within two part 1 and part 2 of the lecture 3, we discussed a lot about the DIKW model, modern DIKW, and then in this page we touched to program enrich DIKW model. And I try to open new and interesting, ideas through this slide. And as you may remember, that in the previous slide we try to show that program add to this pyramid, and the result, program, this is wholly program part. This 2 is a program. So these 2 components add to this section. So let's take a deep dive into how Nicholas-Wirth equation, that means program equal data structure and algorithm, maps perfectly onto modern DIKW pyramid. This model not only enriches the DIKW pyramid with the notation of programming, but also shows how traditional algorithms evolve as we move from data to optimized action in the modern AI system. So this is very good. So what I am going to talk about this here, that mapping from this part, this section of pyramid with this section of the program. So this is the data structure concept. So I will talk about this mapping part. Then I will try to talk about the mapping of algorithm to information, knowledge, wisdom, insight, and optimization. Then I will try to talk about what is the movement from explicit to implicit. And I will give you some explicit and implicit meaning. And in the optimization as a peak of the algorithmic intelligence, I will talk something about that one. And also evolution of algorithm, I will talk. How algorithm evolved. So we have many things to discuss within this slide. So this slide is very important because you never saw this slide before. I created for this class to very professionally, this class, although is for undergrad student, but I'm very professionally put many, specific and new knowledge. It looks like you are PhD and master student. Then when we practically hands-on some practice and exercise, then you will feel difference from just doing something without pre-knowledge or doing something with some knowledge. Okay, let's talk about the first part. So this part, so first part, mapping between this data and with the data structure. So at the base of the pyramid, we have a data, right? Or big data is here. This is corresponds directly to the data structure component in the Wirtz equation. Data structure is how we organize raw data in memory, where we are talking about simple arrays, linked lists, other stuff, or more complex database. Think about an e-commerce platform. Data structure here might be a database of all customer transaction or an inventory of product at this stage. The data is just collected and stored. Yeah? There is no real meaning yet. But it is organized in a way of allow us to retrieve it efficiently. For example, in a hospital system, data structure could be a table that stores patient records. The table holds fields like patient name, age, medical history, but at this stage, it is still just raw data. So now, let's touch this mapping between the algorithm with these four components. As we move up, in pyramid, we began to introduce the second part of the Wirtz equation, algorithm. The role of algorithm is to process and analyze data, transferring it into something meaningful. At the information level, algorithm clean and organize data in, here. Algorithm clean and organize data into something usable. At the knowledge level, algorithm contextualize the information to generate insight. As we move, to wisdom insight, algorithm begins synthesizing multiple data points to predict outcome. And finally, at the optimization level, advanced algorithms like AI and machine learning refine this decision, which machine learning start beginning from here, learning from data and making intelligent automated adjustment. So how does this apply in practice? So let's little bit talk about the tradition algorithm, vice versa of AI algorithm. From explicit means open. If something open, clear, explicit. Something implicit means not clear. When you say, I want water to drink, clearly you said what you want. Everybody knows. When you clearly say to machine what you do, step by step means explicit. But sometimes you have in your mind and somebody who loves you, attention to you, to your feeling, your gesture, and collect many of your attitude. She or he, since love you, try to predict that you need water. This is different from here. I want water. But here, implicitly you have in your mind, your attitude, your gesture, some intelligence. So AI means something lover. So AI is equal simply as a love. The system is love you. Is like lover, implicitly detect what you need and automatically in the optimization level give you many good things. Learn step by step here. Here I want water, many things. The lover learn from your attitude, your gesture. Now is the time to give you water even you don't say. Wow. Wonderful. I wish you understood what I'm trying to say. Earlier in the, pyramid traditional algorithm, like sorting, searching, are explicit. Let me talk a little bit technical. Searching, sorting algorithm do problem solving step by step. This means we tell the computer exactly what to do step by step. We define rules and computer follows them. These algorithms are simple and follow a clearly defined set of instructions. However, as we move higher up the pyramid, particularly in the wisdom optimization stage, algorithms become more implicit, lovely base, quiet, you don't talk, system understand everything. This means they are no longer just following rules that we explicitly define. They began to learn from data itself, adjusting their behavior based on the pattern they observe. So let me give you one example. Let's compare two examples to highlight difference between the explicit and implicit algorithm. Explicit, here, like for traditional navigation system, when we explicitly tell to program how to calculate the shortest route using fixed road distance. Every decision is pre-programmed based on the known rule. For example, if road X is shorter than road Y, choose road X. This is here. I'm giving you a very wonderful example. Please pay attention. Explicit. In the contrast, a modern self-driving car uses implicit algorithm. It doesn't just follow preset instruction. It learns from its environment using AI. The algorithm observes traffic pattern in the real time. So that's why many algorithms we use, it doesn't fit to the reality because it is mostly explicit. But some algorithm, for example, if you use the navigation in your company, in your car, which not connected to internet, it's different from navigation which using the Kakao map or Google map online connected to the server. So you can feel difference. They give very long distance in the high traffic. So I'm not talking about that Kakao map or is a totally implicit. It's here somehow. It's still far away. So I'm talking very high self-driving car. In this case, which using the implicit, it doesn't just follow preset instructions. It learns from its environment using AI. Algorithm observe traffic patterns, adapt to unexpected obstacles, and make decisions based on the data on the road. It continuously gather and continuously make a decision ready every time. Not one decision, a streaming decision. Such a system which control the speed continuously, automatically. Speed limits, traffic density, weather conditions, everything influence the automatic decisions. It isn't, this navigation, self-driving, modern navigation, it isn't clearly, we should not say clearly, we should say explicitly, because we already introduced explicit. So it isn't explicitly means it is implicitly told how handle each scenarios. During the day, many scenario. It learn what work best from experience. Wow. What works based on what we learn. So, as we see optimization here on the top, at the very top of the pyramid, we reach this one, which represents peak of algorithmic intelligence. Here is, as you saw, let me show you the different color. Which color is good? Maybe this. So you see is this is intelligence of algorithm is increasing. This is where modern AI algorithm truly excel. They don't just execute a decision. They continuously improve those decisions based on learning from outcome and making adjustment in the real time. Let me give you one example. Consider a recommendation system like Netflix. Early in the process, system might recommend a movie based on the user viewing history. If system can do, this is the wisdom in this level. If Netflix just do based on the user viewing history, many process done from here come to the wisdom level. But in the optimization stage, the system goes further. It tests different recommendation tracks which suggest user engage with and refines its recommendation to get better over time. This is where machine learning play key roles, and the system is constantly optimizing based on the feedback. Wow. So this is, we see how this evolution of the algorithm through the pyramid happen. As we move up from the pyramid, we can see evolution of algorithm in terms of their complexity and intelligence. You know, in this information, at this stage, algorithms are mostly cleaning, organizing data. For instance, they might remove the duplicate or fill missing value from data set. Here. Here, in the knowledge part, algorithm, because this is not about the algorithm, this is just... So in this, algorithm start from this stage. So here algorithms start to make sense of the data. For example, this machine learning algorithm identify cluster for user and share similar behavior. For here, at this point, algorithm is synthesizing knowledge and making predictions. For instance, it might predict which customers are most likely to purchase a particular product. And optimization, in the final stage, the algorithm does not just make predictions. Here is prediction. Many AIs here. But it acts on them and refine its action based on the result. For example, AI system might automatically adjust pricing based on demands pattern to maximize revenue. Can already existing AI system can do? No. Many systems who claim that they are AI, but they are not AI. So this is the point. We need to consider. I think it's enough. I already explained. But little bit, let me touch. What is this? Here add context. Here add what? Plus meaning. Here plus. Why don't you ask me to explain? And please pause the video. Class assignment. If here was a face-to-face classes, I definitely one by one ask, what does it mean? We add context to data, we add meaning, we add insight, we add actions. What really means? This is the class assignment, not homework. You don't need to send me. Just answer during the class. Pause the video and answer to me. It is very important. Please follow my instruction. When I ask pause the video, you must pause the video and answer, then play again. Okay. Okay, here I put many, many things I would like to share. Sometimes you cannot find in the slide because it's very difficult to put. Sometimes when I teach, many knowledge come to me. Even I didn't think before. When I try to teach, many things come to me that I explain this point, it is better. So sometimes I don't know what should I put in the some slide. When I teach, the idea and examples come. Okay, as you saw in the context part, so here we are going to add data to here. Context to information. So, okay, now let's take closer look at the steps that guide data transformation within, this modern pyramid. Let's call it program enrich modern DIKW or DIKO pyramid, and how certain elements like context, meaning, insight, and action help us move from raw data to fully organized outcome. So this context, we have a context which is key turning raw data to usable information. So from data to the usable information. Raw data is its own, doesn't tell us much. It's just number, click, actions. By adding context, we can start to understand data more clearly. For example, if we collect information about the user visiting a website, adding context might mean sorting them by their device type, location, or time they spend on the site. This context give raw data structure and make of actionable and transform into the information we analyze. So this is the context. We add this is basic context. Here when we come to the knowledge, also we add context. You remember we call it contextualize in the knowledge. But here is the basic context. Here is context plus meaning. So next here we move to meaning, means context, meaning-based context. At this point, we take the organized information and interpret it. Meaning, helpful us to see bigger picture here. For instance, if we discover most of website visitors are using mobile devices during the lunchtime, the information becomes meaningful. Now we know that the site needs to mobile friendly, and we could even consider offering a special lunchtime deals to engage these users. So adding meaning allows us to go from just having information to actually understanding what it presents. Let's go inside. Then we come to inside where things get really interesting, because it is about the combining piece of knowledge to predict outcome. Let me give you an example. After studying user behavior over time, we might notice that customers who visit the site during a sale are likely to make a purchase within 24 hours. This insight is valuable because it lets us to anticipate what customers will do, allowing us to make strategic decisions. Like when to run a specific marketing, companies, this is the point. Then in this way, insight help turn our knowledge into wisdom. This is very helpful knowledge to the wisdom. Then action. Finally, we have action. Wisdom go optimization, because in optimization we have more action. We have action, which is all about putting insight into practice. Once we've identified that user tend to purchase during a sale, we can take action by sending personalized promotions at just right moment. This is where the AI algorithm truly shine. We will see the importance of the AI. Really, AI shine here as they continuously learn and adjust this action in the real world. Action come to the real world. Remember, we come from physical world, cyber world, back, go. As the system collect more data, it optimizes this actionable data to the actions automatically, and ensuring every decision is refined and more effective during the time and over time. This transition from the wisdom to the action represent the ultimate goals of the optimization. This is the, you ultimately reach to our decisions. So, as we can see, each of these elements, context, meaning, insight, action, play a crucial role in the transferring data from raw state into something that not only informs but drives smart. In optimization, everything getting smart, more smart, and optimized decision. This is path from data to action in the modern AI, driven world. As a conclusion, to wrap up this part, the rich equation program and data algorithm align perfectly with the modern pyramid. So the data structure represents the foundation of any system where we store, organize the raw data. As we move up the pyramid, algorithm become more sophisticated, transferring data to information, knowledge, wisdom. As here we mentioned, adding the plus context, plus meaning, plus insight, plus action. This is the key takeaways in how algorithm evolve from the being explicit rule-based system to implicit AI, driven model that optimize decision automatically. This journey from data to action is what power modern AI systems. So this is the result of the enrichment. We already discussed a lot. So let's go little bit see what is the power of the enriched model. So when we come to this model, which we introduced earlier, program enriched model, What is the power of that? This model simplifies our understanding how program, data structure, and algorithm works within the, our pyramid. Data structure from foundation is the base. So this is the very critical understanding. From the foundation at the base of the pyramid, where the raw data is stored and organized. But it is, from some point, it is the algorithm that drives the transition upward from data to information, from information to knowledge, and so on, finalizing in the optimization. So what we are going to explain here, that algorithm start by organizing data into usable information, then contextualize this information, turning into the knowledge, then go further by synthesizing this knowledge, giving us wisdom or insight. And in the top of the pyramid, that the algorithm achieve optimization, where the AI system doesn't just make decisions. They learn, improve, and refine their action over time. In the lower of the pyramid, traditional algorithms operate explicit instructions, meaning they follow rule. This is the rule-based, when we say explicit, that are defined by human. But as we move higher through the, in the pyramid toward the optimization level, we begin working with a more advanced AI algorithm that can learn implicitly from data. Please attention word by word which I am mentioning. This intelligent algorithm optimize their action automatically based on the feedback they receive. So I would like to emphasize that the way I've structured this course and this model is highly created and unlike anything you've seen before. Please attention. You are not just learning concept here. You are learning a new way of thinking about how AI and big data can be integrated through programming. Please attention. Several times watch this video. This method which I am using in this lecture will completely transform how you approach your research and career. I urge you to embrace of this model and revisit this lecture multiple times to fully grasp its value. The program enriched model will serve as a cornerstone for your understanding of the AI and big data. Remember, this is the first time in the whole world that the AI and big data are being taught from this perspective. You never saw such a lecture. Believe me, I'm not exaggerating the value of this class. As your professor, remember that Abul Qasim, Sadeghi, Niaraki are currently working on publishing an academic paper and a book about this model. And you are at the forefront of this innovation. I don't know you get my point or not. I wish I had more time to go into all incredible detail for this model, but I hope I've seen and I've given you enough to spark your curiosity. I encourage you to reflect on this model deeply. In the cyber board, cyber class, I cannot too much communicate and wait for talk about this model many. And we cannot meet each other. So you should practice by yourself, as it is a potential to change your entire academic and professional trajectory. This problem enriched model is not just a concept. It is tools that shape your future of AI and big data applications. So these slides which I mentioned, it is not easy. You easily, try to forgive it. So I ask you to take this seriously, study this model carefully, think about how it can apply to the challenges you want to solve in your career, and understand that you are part of something truly, groundbreaking. So, once again, this model represents a new way of teaching of AI and big data. Really a method that will help you understand. Please review. Really, I'm proud to share this innovation with you, and really, I'm very excited to you see from my son how it transfer your journey in the AI. Let me finish this part. Just simply see last slide of this. Let me clean the slide, and just as a scene attached diagram. Data is foundation. Algorithm or engine that drives transformation through each state. These follow starting from raw data and moving all the way to optimize decision, create solution to complex problem in digital world. As you already I discussed, whether it is recommending the best product to the user when we come to this solution, I think I already explained too much about this. Now is the evolution of a data handling practice as a section 2. Section 2 will be I continue for the coming lectures, because I try to quickly talk, but many things to share. And so time quickly pass. We reach to the beginning of page 28. So for lecture 4, we will start from this slide and try to, give you more concept here. So let me give you some instruction. Please attention. So first instruction, watch this video lecture multiple times and take detailed notes. Second, try to reflect on your insights. What does it mean? behind the fact, try to write down, jot down your personal thoughts or mental association triggered by the video content. Number 3, you need to expand your learning. What? How? Of course, after taking note, revise them and do additional research to deepen your understanding of topic covered. So this needs self-directed learning, right? For these 3 which I mentioned, you need to why self-directed learning? Because of nature of our class, given the virtual nature of our class, it is essential that the student actively review and practice concept covered in this lecture. And one more point, which is very important. What is that point? One news. Few lectures later, practical sections ahead. So, get ready. Why? Soon we will start combining hands-on practice with theoretical concept. While I will do my best to simply key points to truly master the materials, you'll need to be comfortable navigating with some programming language, especially for Python programming. So especially you need, as I many times mentioned in the syllabus mentioned few weeks later, a few weeks back, I already mentioned, I am not expecting you professional in the programming. I will start from the very basic, but you need to something to know, not just start Python with my class. I have big plan to teach you many things. Many things means you should increase my speed, quickly pass from the basic, go to the big issue. Then you will learn many things. So promise me, because I encourage you to explore and study more detailed aspects on your own. If there is one good news. If you haven't had a chance to dive into Python yet, don't worry. Why? Because there is still time. Don't lose your hope. Start today, and you will be well prepared for practical section to come. Okay. So I really want you to start Python from now. Watch YouTube channel, many materials. Some of you know is okay, because I need to quickly finish this part and then go for the practical part. In that case, you need try to learn and read something regarding my slide already. Read something, remember, prepare yourself for exam. So we will have an assignment exam coming. Okay? So promise me. Okay? Thank you. So for the next lecture, I will dive into evolution of data handling practice. searched what is the meaning of this. Then I will come to you. Okay? Thank you for attending today's lecture.